All right, assignment 6.6. As always, you should press pause, do it first yourself, then press play for each question. A limit question, we first just evaluate at the numbers. So in other words, evaluate at 2, that's 0 divided by 4, so the answer is 0. Write down, press pause, write down number 2. Evaluate at 1, that's 0 over 0, that's indeterminate. So L'Hopital's rule says take the derivative, and then you can re-evaluate. So I take the derivative, re-evaluate at 1, and the answer is 4. Number 3. Evaluate at 0, and the answer is 0 over 0. The derivative, and again, if you evaluate, it's indeterminate. So one more time, don't ever forget the limit notation until the very end, and then you can get your answer. So it's e to the x over 2, plug in 0, and it's 1 over 2. Number 4. The limit as x approaches 0. First of all, evaluate at 0. So e to the 0 is 1, so this is 0 over 0. This is L'Hopital's rule because it's indeterminate. Now a negative, now 1 is 0 obviously, but negative times a negative makes it plus e to the x. Plug in 0, and again you get 1/2. Number 5. So what's the value of the limit from the right? So pick any number bigger than 0, and the answer is always going to be positive 1. If you pick from the other side, if you evaluate any number smaller than 0, so like negative 1, the absolute value of negative 1 is 1 divided by negative 1. So one answer is positive 1, the other answer is negative 1. So exactly at 0 then, the limit doesn't exist because the right says 1, the left says negative 1. They don't agree, so the limit doesn't exist at 0. Number 8. The limit as x approaches 2. So if I plug in 2, it's 0 over 0 because ln 1 is equal to 0. This is L'Hopital's rule. That's 2x. That's the derivative of the logarithm. Plug in 2, and now it's 4 over 1, or just 4. Number 9. Again, press pause. You need to do it first, then press play. Evaluate at 0, and it's indeterminate. It's 0 over 0. The derivative of 2 times e to the x is 2e to the x. The derivative of negative 2 is 0. The derivative of x squared. Again, if I plugged in 0, e to the 0 is 1 over 0. That doesn't exist. That is not indeterminate when it's a number over 0. That just doesn't exist. Number 10. This is an end behavior question when it has to do with infinity. So if we know our end behavior, that's very helpful. So for here, end behavior, power term over power term, they match, so the answer is just 2/3. For number 11, the limit as x approaches infinity. So again, end behavior, the top is not as powerful, the bottom is more powerful than the top, so that answer is 0. Ignore this, I don't know what this is. 12. The limit as x approaches infinity. Know that the numerator increases faster than the denominator. So that means this is going to infinity or doesn't exist. Number 13. Again, an end behavior question. The limit as x approaches infinity. 3x to the 5th plus x to the 4th minus 5x. 2x to the 4th minus x squared. So when the numerator is more powerful than the denominator, it diverges. It doesn't converge to an answer, so either it's infinity or doesn't exist. The square root of x squared plus 5 over x. End behavior, so the square root of x squared over x, that's positive x over x, which is 1. The same question pretty well, but the left end behavior here. So when I look at the power terms, the square root of x squared, the answer on the left would be negative x, and the answer on the right would be positive x. So this answer is going to be negative 1. The limit as x approaches 5. That answer is just evaluate, and it's 0, not indeterminate. Again, press pause. Got to know our unit circle a little here. So the value of tangent at 0 is 0. 0 times anything is 0. It's indeterminate, so we need to do L'Hopital's rule. Take the derivative. That's secant squared, the first times the derivative of the second, plus the second times the derivative of the first. Evaluate at 0. Secant at 0 is 1. So, and 0 times anything is 0. This whole thing ends up being 1 divided by 1, or just 1. Number 18. The limit as t approaches pi over 4. Cosine t minus sine t, 2 minus 2 tangent t. So if I evaluate at pi over 4, it's 0. If I evaluate at pi over 4, it's 1. So 2 take away 2 times 1. This is indeterminate. So I'm going to apply L'Hopital's rule. So the derivative of cosine is negative sine. The derivative of sine is cosine, but it's negative because it was negative. Derivative of 2 is 0. This is negative 2 secant squared. And then evaluate at pi over 4. Sine at pi over 4 is root 2 over 2. Secant is the reciprocal of that, so it's 2 over root 2 squared. So this becomes negative 2 root 2 over 2. This becomes negative 2 times, that's 4 divided by 2, which is 2. These cross out. 2 negatives become positive, so the answer is root 2 over 4. Number 19. The limit as theta approaches pi over 2. So if I evaluate at pi over 2, another way to write this is to separate the numerator and denominator. So if I want to understand this, then plug in pi over 2 here. And I just want you to recognize that when you plug pi over 2 in, the 2's cross out, and the y coordinate at pi is 0. If I looked at the denominator separately, this is a much better way. Otherwise, if you write 0 over 0, you'll get a point taken off the exam. So evaluate at pi over 2. So at pi over 2, the x coordinate there is 0, so it's indeterminate. Take the derivative. So the derivative of sine is cosine, but then there's a hook. The derivative of cosine is negative sine. And then evaluate at pi over 2. So 2 times pi over 2 is just pi. And the x coordinate at pi is negative 1, so it's negative 1 times 2. At pi over 2, the y coordinate is positive 1. So a negative divided by negative, this answer is going to be positive 2. Number 20. So the derivative of arctangent x is a fraction. It's 1 over 1 plus x squared. Well, first of all, if you plug in 1, the value of arctangent at 1, the angle is pi over 4. Take away pi over 4, which is 0. 1 take away 1 is 0. It is indeterminate. Now take the derivative. So the derivative of arctangent, the derivative of pi over 4 is 0. and the derivative of this is 1. So now plug in 1, and you see what the answer is, and it's 1/2. 21. These are the a little bit longer questions. So to evaluate this limit, we're going to let y equal this. And then we're going to do the ln to both sides. So we have ln y equaling the limit as x approaches 0 from the right. And then this exponent can be written in front. Now I'm going to write this so we can do L'Hopital's rule. So this is 3 times e to the x plus x over x. And then, all right, 1 second here. I'll be right back, number 20.